A company offers earthquake insurance. Annual premiums are modeled by exponential variable mean 2. Annual claims by exponential variable mean 1. Premiums and claims are independent. Let X denote the ratio of claims to premiums, and let F be the density function of X. Find Fx where it's positive. So let's call the annual premiums as R and annual claim as C. So I'm not calling the annual premium as P because P is a symbol which we use for probability. R is the next letter, so I'm using R for premium, C for claim. And for the premium, the mean is 2 and it's exponential, so it would be 1 over 2 e to the negative r over 2. The PDF, remember the PDF for exponential is 1 over k e negative x over k if k is the mean. So for the claim, the mean is 1, so the PDF will be 1 over 1 e to the negative c over 1. Now claims and premiums are independent, so the joint PDF will be just the product of the individual PDF. So you multiply these two and you get half e negative r by 2 e to the negative c. And we need to find little fx, and x is the ratio of claims to premium, right? They tell us here x is the ratio of claims to premium. So x is claims divided by premium. And we need to find little f of x, and as usual, we first need to find the CDF, or the big F. So CDF of x is equal to probability big X is less than or equal to little x, and big X is C over R, so it's probability C over R is less than or equal to X. And if we write it as C is less than or equal to Rx by multiplying by R on both sides, then the advantage is that we know the region right away. So we know that the claims are positive. So C is between 0 and Rx because of here. And R is between 0 to infinity because in general, R is bigger than 0 for the exponential, and R is the annual premium, and there is nothing which is telling us that there is any limit to it. So it would be 0 to infinity. So therefore our region will be, if you keep the C inside, C goes from 0 to Rx, 0 to Rx, dc, and R goes from 0 to infinity. Remember the constant limits have to be outside. And the double integral is taken for the PDF. So PDF we above saw above was half e negative r by 2 e negative c. Now, when you're integrating with respect to c, the half e negative r by 2 is a constant. So half e negative r by 2 is a constant, and the integral of e to the negative c is negative e to the negative c. So that negative is over here. And then c goes from 0 to rx. And when you put c equals rx, this is e to the negative rx. And you put c equals to 0, e to the 0 is 1. So you get that. And now I pull the negative half out, and I distribute the c negative r by 2 to make my integration easy. So this would be e to the negative r by 2 minus rx when I multiply this with this. So that means negative of 1 by 2 minus x, and is what I get after I factor out the r. And the reason I'm putting it in this form is, remember, the next integration is going to be with respect to r. So I know that the integral of e to the AR will just be e to the AR divided by A. So that's why I want to write it as a multiple of R if possible, and I can. So this one, when e to the negative r by 2 gets multiplied with negative 1, is just negative e negative r by 2. And so, as we said here, e to the AR integrates to e to the AR divided by a. A was negative half minus x, and that's this negative half outside. And then I'm distributing this negative half over here also. So negative half times negative 1 is plus half. And e to the negative r by 2 integrates to e to the negative r by 2 over negative 1 by 2, right? E to the ar integrates to e to the ar divided by a, 0 to infinity. And now I do one little simplification before putting in the limits, and that actually is helpful. So when this negative, so we have a negative 2 at this level because of this negative half. So negative 2 times negative half is actually 1. And then negative 2 times negative x is plus 2x. And this one now, I factor out the negative from these two and put it with this r. And you will see soon why. This one, half, so 2 times negative half is negative 1, so negative outside and e to the negative r by 2. And now when you put in the infinity, we learned a while ago that e to the negative infinity goes to 0. So that's why I wrote it like negative r, so that I can see that it would be negative infinity here times something positive. So the overall would be e to the negative infinity, and e to the negative infinity is 0. Similarly here, e to the negative infinity by 2, that'd be 0. And the lower limit is 0, so this one is negative. E to the, so this is 0, so this zeroes out the whole thing, so e to the 0 is 1, so minus 1 over 1 plus 2x, and then this becomes positive e to the 0, which is 1. And then I don't need to rewrite it because that's not the answer I want the little f. So this was the big F, and then the little f is the derivative, so only this term is a non-constant term, others are 0. For the derivative of 1 is 0. And then this one can be written as 1 plus 2x power negative 1. And then when you use the power rule and the chain rule, you end up getting 2 over 1 plus 2x square. And that is choice B.